Chapter 11, Section 11.2. Now, this time we talk about contingency tables. In this part, in the first part of this discussion, this section, we present a method for conducting a hypothesis test of the null hypothesis that the row and column variables are independent of each other. This test of independence is widely used in the real-world application. And the second part, we don't go through that one because it's not very common. Now, again, we are using basically the same formula. And what is your HO and H1? Here, HO is the row and column variables are independent, and alternate hypothesis is saying that row and columns are dependent. So these are our null and alternate hypothesis. One of the difference here is E. E, expected frequency, has different way of calculations. So I'll show you an example that if you want to find the E, you have to find the E for each observed value. And you take the row total times column total divided by grand total. So here, so what is in contingency table is two-way frequency table. Is a table consisting of frequency count of category of data corresponding to two different variables. One variable is used to categorize rows, and the second is for columns. Again, most of this, when you see the example, is easier to understand it. Like if you want to calculate degree of freedom is different here. It is R minus 1 times C minus 1. R is number of rows, and this is number of columns. All right. Let's look at this example. In this table, 11.6, there is a contingency table with 4 rows. So there are 1, 2, 3, 4 rows and 2 columns. Observed frequency are these numbers: 54, 41, 70, 17, 12, 51, 35. These are observed frequency that are given in the problems. The one in the parentheses are expected frequency that we need to calculate. Okay, so what we do here first is, so these numbers are given. Observed frequency is 54, 12, 41, 51, 73, 17, 5. Now you need to add the total for each row and each column. So like 54 plus 12 is 66, 41 plus 51 is 92, and so on. And here you add all these 4 numbers: 54 plus 41 plus 17 plus 17 is 182, and so on. Now, then you find the total numbers. You add all these numbers, it's 253. And also, when you add 182 to 71, you should have 253. So first, you got to make sure that your table is correct. How do I know it's correct? By adding these numbers and these numbers, and in either case, you come up with the same value of 250. 253 is the grand total. So here, grand total is this 253. Now, let's calculate the, for instance, for 54. Okay. 54, it said row total times column total. It means this 54, this number is on the first row. On the first row, you have the total is 66. 54 also is on the first column. So total in the first column is 182. That's why you have 182. And this is a grand total. Okay? So again, for 54, 54 is on the first row. So what's the total on the first row is 66. Is also on the first column is 182, and then divide by grand total. For instance, let's say I want to calculate for 5. 5 is on this row, which is 22. Five is on this row, the total is 22, and is on these columns, so it's 71 divided by total. Okay, let's say you want to calculate another one like 70, okay? 70 is in this row. So it's 73. And 70 also is in the first column. So it's 182 divided by total 253. That's how you calculate all of them. And then you put all the numbers here, okay? So then you have to create a table very similar to the one we did, right? You have a table which has all the O, the table has all the E's, do a subtraction, all this. Now, also is imperative to use a calculator for this section because it's a very, very long calculation if you want to do that, okay? Then this one, first you got to calculate all the observed frequency one by one, right? Then you got to make a list for all the observed one, which is 54, 12, 41, and then also for the E, and then do all the subtractions, which I'll show you in the example how to use a calculator. Critical value is very similar, okay? And what DF is R minus 1 times C minus. How many rows do you have in these problems? There are 1, 2, 3, 4. 4 rows, right? So that would be 4 minus 1. How many columns do we have here? 1, 2 columns. So it would be 2 minus 1. 4 rows and 2 columns. So that would be 3 times 1 or 3. So your DF is 3. And alpha is given, that give you that 7.815. Okay, all right. Now, to do the calculations, you need to actually create a matrix here. And this is the page that you need to put in front of you when you want to use the calculator, okay, to have the matrix. And then I guess and these are, I did one of the problem, I think it was number 1, okay, look. This one, results from a civil servant exam are shown in the table to the right. Is there a sufficient evidence to support the claim that results from the test are discriminatory and use 1% significance level? So these numbers are given, okay? So we need to do all the calculations. All right. So I'll put those numbers here. But before I do the problems, I have to use the calculator. Second x to power of 9 is the matrix. So if you want to find a matrix, you see that matrix here is blue. So you have to put the second and then this one. But see, from the previous problem that I did, there are some numbers here. I don't want this, okay? So if you want to erase this, you could either go all the way to D, or if you want to erase this, anytime you have a matrix you don't want it, they're saying, okay, go to the second plus second plus now number 2 is this memory management. Go to that. Okay, enter. Do you want everything erased? No, I just want a matrix. So let's just scroll down to number 5. See, do you want all? No, I think you just want to delete the matrix. And then enter. Okay, do I want delete A? Yes, go to delete. Do you want to delete this? Yes. Okay, so I shouldn't see any matrix now. All right, so now I'll start here. Go to your matrix first, second, right. Go to edit, okay, enter. My matrix is, what is it? Is 2 by 2. See, you always put number of rows first and then number of columns. There are 1, 2 row and 2 column. Most problems are like that, but here is 2 rows and 2 columns. So number of rows first and then number of columns. When you want to create your matrix, you need to have number of rows, number of columns. So this is 2 by 2. So here I put 2 and then go to 2 again. Okay, enter. Now ask you to put the numbers. It's 16. 16, enter. Second number is 15. The third number is 11. And the fourth number is 23. Okay, so I have all the numbers in the matrix, okay? Now, when you enter all the numbers, now go back to your matrix, second X1. Second that to the matrix. And then go to math and scroll down to number 9, I think, to see that list arrow MATR, okay? Now, here, it asks you which matrix. We go to second, we are here, ask which matrix. You go to the second matrix and then enter. See, you have it now. So it wants you to calculate matrix A. Now we go to stat, test, go to, oh, sorry, stat, test, go to X2 test. X2 test, you should see this, observe expected. So you don't have to do anything, just to scroll down to expect, calculate. Now it gives you X2, which is 2.47, test the statistic. Also give you the p-value is 0.11 and the DF is 1, we know, right? Remember that the DF is, let me write it here. DF is C minus 1 and column, what, it doesn't matter what the other year really is, C minus 1 or what's the other ones? All minus 1 and C minus 1. Okay, how many rows did we have? 2. 2 minus 1. How many column? 2. So it would be 1 times 1 or 1. That's why you have DF1 here, okay? All right. So now, see, if you want, I also show you the hand calculation. See the difference? If you want to do hand calculation, you have to calculate the E for each. Like for instance, how do I calculate for number 16? Number 16, if you want to calculate expected frequency for this, 16 is in this row, so it's 331, and is in this column. So it's 31 times 27, grand total is 65, and so on. See, I'll show you in this example the difference of hand calculation versus that, okay? See, if you want to use hand calculation, let's say if you take the test, well, right now it's online, but if you take it on campus, when we give you a table like that and we ask you to fill all these numbers, then you got to do all this. Okay. But now, I think to do the homework problems, if you first you need to understand the concept, but then you just use this method and it gives you all the values that you want. Okay. And if you want to find your graph, DF is 1, and what was the alpha here? Alpha is 0.01. 0.01 is the alpha, so we go to table F4, DF 0.01 is this numbers, and DF is 1, so it's 6.635. And where does that 2.4 fall? Here, right? 2.4. So in that case, we accept HO, we do not reject HO. And also our p-value is 0.11. 0.11, which is our p-value, is greater than 0.01 alpha. So that also proves that we have to accept HO or do not. So these two should always match. Means if you want to accept HO or if you do not want to reject HO, your test statistic must fall into the good area, not into the critical ones. And the p-value has to be greater than alpha. All right, so that's how to do the calculation for this section. I think I have, let me see, I think I have one more problem like that for you. This one, this is also very similar to that. I'll show you how to use the calculator for it, In these problems, you have 2 rows and 4 columns. See, 2 rows and 4 columns, so DF is 3. So when you create a matrix, it has to be a matrix which is 2 by 4. So if you go to second matrix here, you go to edit and go to B. B is empty. And then it's what? 2 rows, 2 rows, and how many column? 1, 2, 3, 4, 4. Okay. And then you could input the numbers here. When you enter the numbers, just follow the rules. Okay. And I'll show you how to do it all this here. All right. So that probably helps you to do the homework problem for these sections.